So trigonometry to this point has all been about right angle triangles, right? SOHCAHTOA. And that's SOHCAHTOA only works for right angle triangles. However, there are two rules that we're going to learn about that are for non-right angle triangles. And it does sound a little bit confusing because the first one is called the sine rule. And we kind of already know that for right angle triangles, sine is opposite over hypotenuse. But for non-right angle triangles, this sine rule can be used for these couple of situations here. The first time it can be used is if you have one angle and its opposite side length, and you're trying to find another side or another angle, or another side or, that's very weird the way that's been worded. Okay, I'm going to reword that, so don't like how that's worded there. What you're going to have is you're going to have an angle and a side opposite, and you're either going to have another set where you'll have an angle and a side opposite, but one of them will be missing. Either one of the angles will be missing or one of the sides will be missing. But it'll be two sets of opposites, okay? So this labeling that is in this triangle, this is how we use the formula. All the angles are capital letters. So capital A, capital B, capital C are the three angles that are in there. The lowercase letters are the sides that are opposite those angles. Okay, so capital A is here, little a is directly across from it. Okay, now the formula is this. You'll have to write this in the space, please. Little a over sine of capital A is equal to little b over sine of capital B. Now, there's actually a third one, which is little c over sine of capital C. Now, we don't ever try to solve a problem that has two equal signs in it. What that formula means is it depends on whether you're using the A's, the B's, and the C's. You'll either be using like A and B, or you'll be using A and C. You choose the two parts in there that you're actually going to be using. Okay? Also, though, the way that formula is written, all the little letters are on the top. So that formula is best if you're trying to find sides. Okay, find sides, we want the little letters on top. If you were trying to find an angle, then you can turn that whole formula upside down, which would be sine capital A over little a, sine capital B over little b, and sine capital C over little c. Okay, so those are the two formulas that we're going to be using. Now, just to throw some extra information in there for you, there is what we call an ambiguous case. When you are using the sine rule, if I give you some information, like in these diagrams here, you have side C is 6, you've got an angle of 30 degrees, and you've got side A is 10, and maybe you want to try and find this angle in here, this angle across from that A there. What we don't know is whether that angle is acute or whether that angle is obtuse. The sine rule formula works for either one, okay? But it will always give you the acute angle. If you know, and you will know because the question will tell you that this should be an obtuse angle in this triangle, then you have to put it into that second quadrant or into make it an obtuse angle by doing 180 minus the angle that you found. Okay, so it's one little extra step that you do if you know it's going to be an obtuse angled triangle. Okay? All right, so that's the theory part. Let me show you how to use this formula. Example number 1. Find the value of x in the following triangle. There's not even any A, B's, and C's, so I'm going to put those on there for this first one. I'm going to make little a the side that I'm trying to find. That means that capital A needs to be the angle across from it. And I'm going to call little b the 12, which means the angle across from that is the capital B. Now the x that I'm trying to find is a side, isn't it? So I'm going to use the version of the formula that has the sides on top, which was a over sine capital A equals B over sine capital B. Remember, I only need two of them. I don't need the C over sine C. You only need two. So I'm using A's and B's, okay? So I'm going to substitute into that formula. Little a is the x that I'm trying to find. Then it's sine of capital A, which is 62. Then on the other side, we have equals little b is 12 over sine of the capital B, which is 45. Now the whole goal is that we're trying to find out what that x is. So to get the x by itself, you're going to times the denominator, which is sine 62, across to the other side. There's two places that you can write that, and it doesn't matter which one you use, but you need to be aware of both of them, because sometimes in multiple choice questions, they'll put it in different places. So you can either put the sine 62 up here on the top of the fraction, because you're multiplying it to the top, or the other option is to go times sine 62 out the side, which is probably the more natural thing that people want to do. But just be aware that that does mean it's being multiplied to the top, if you happen to see that in a multiple choice question, where they don't want you to find the full answer, they just want you to show that it gets to that kind of thing there. Once you get that to that point, we just want to type all of that in your calculator. Okay, so grab your calculators out, you get 12 over sine 45 times by the sine 62. And I did this to 2 decimal places. You just want me to tell you, don't you? Oh, okay. 14.98 centimetres. Okay, that's to 2 dp. Okay, wasn't so bad, was it? Let's try it again. That's the sine rule. Question 2. Find the value of theta in the following triangle. Okay, so we're finding an angle this time. Because there's no other labels on there, I'm going to call the one that I want to find the A. But this time it's a capital A because I'm trying to find an angle. The little a is going to be the side across from it. And then capital B can be the other angle, and that means little b is the 15. So this time, because we're finding the angle, we're flipping our formula, and we're going to have sine capital A over little a equals sine capital B over little b. It is possible to always use the same formula, like the first formula. It's just harder to rearrange if your pronumerals are on the bottom. So it's always just easy to flip it, so your pronumerals are always on the top, and it's easy to times your denominator across. So sub into that. Sine A is the theta that I'm trying to find, over little a, which is 18.5, equals sine capital B is 40 over little b, which is 15. So like last time, I need to get this by itself, so I'm going to times that across to the other side. You can either times it to be in front of that sine 40, or you could just go times 18.5 out here on the end. Now, if you type that into your calculator, you will get a decimal, which sometimes surprises people. It comes out something like that. But that's because that's still sine theta. To get the theta by itself, what do you have to do? Inverse sine, just like you do with your soccer toe. If you're trying to get the angle, you still have to do an inverse sine here. So inverse sine, so shift sine with that decimal in your calculator, becomes 52 degrees and 27 minutes. Okay, so there's one last question, which is the one where I get to show you our ambiguous case. Find the value of theta in the following triangle, and it says, note, theta is obtuse. You can kind of see that from the diagram, that's bigger than 90 degrees, but it is also telling you that in the question. So the first 90% of the question is exactly the same as what we've already done. I'm trying to find that angle, so I'm going to call that A and little a, and capital B, little b. If a question already has labels on it, you're welcome to just relabel it the way you want to, or you can adjust your formula. You will get, the more you do this, the more you'll get to recognize that it's just angle side opposite equals angle side opposite. It really doesn't matter what the labels are. Or flip them upside down if you want the other ones on top. Okay? So, I have got A is, do you want to write the formula down? Let's write it down because we're still learning it. Sine A over little a equals sine capital B over little b. So my sine A, what I'm trying to find is the theta. That's over 10. Equals sine capital B, that's sine of 30, over little b, there's your beds, over little b, which is 6. Okay, if we want to get the sine theta by itself, I have to times that 10 across to the other side. So sine 30 over 6, and I'm just timesing the 10 over. You will then need to type that into your calculator, and you will need to inverse sine that. It actually comes out really nice as a nice fraction when you type the first part in. To get the theta, when you inverse sine it, is anyone practicing? You should get 56 degrees and 27 minutes. Your calculator will always give you the acute angle, okay? So you then need to know, wait a second, we're told this was an obtuse angle question. So I'm going to say, therefore, theta is actually going to be equal to 180 degrees minus the 56 degrees 27 minutes. Okay, it's like we were pushing into the second quadrant, kind of like what we were doing yesterday, pushing into the obtuse angles. Okay, and when you subtract that, you find that as an obtuse angle, it's 123 degrees and 33 minutes since theta is obtuse. Okay, does that make sense? So just keep an eye out for that obtuse angle question. And that's the sine rule. Oh, which bit?
Does it always have to be in degrees and minutes?
The question will often say, hopefully. If it doesn't say that, it really should say. Sometimes it will say to the nearest minute, the nearest whole degree. Like often the bearings questions in particular, they just want you to round to the nearest whole degree. Sometimes it will say degrees and minutes. Very occasionally it might even say decimal places. Yeah, just keep an eye on the question. If it doesn't say, then you get to choose as long as you do it accurately.